Hello and welcome to another episode of This is Automation Live. I am, of course, your host, Corey Dallas, and I'm super happy to have you with us today to talk about VFDs. VFD is a variable frequency drive. We're going to talk about what it's used for and how it works, and hopefully we're going to make it simple enough that anybody out there can understand, whether you're experienced in all of this stuff or if it's brand new to you and you're just trying to figure it out for the first time. We've got some good content for you today. Coming up next week, we're going to be talking about how robot arms work, more and more pervasive in industry. We're seeing these robot arms used in more and more types of applications. So it's important to know what's actually going on under the hood. So we're going to talk about that next week. So make sure you subscribe to the channel. You can do that by hitting the button down below and hit that bell icon. The other thing you can do, if you didn't know, is actually go to the channel page and scroll through all of the upcoming live streams that we have, and you can set notifications for specific videos. How cool is that? So make sure you do that. Take a look at the upcoming stuff we have. If anything piques your interest, go ahead and subscribe, and make sure you subscribe to the whole channel too, because then anytime we post podcast episodes or anything like that, you'll get a notification. So thank you for those of you that are already subscribed, and we're looking forward to getting to interact with you new subscribers. So let's go ahead and get started without more introduction. We'll start talking about VFDs. So again, what is a VFD? The most important thing to understand is what is it actually used for? So when we're looking at a VFD, it's typically never just a VFD alone. It's almost always paired with a motor. So it's connected to that motor with some wires, and ultimately it's making that motor spin. Now, I said not that long ago that VFD stands for variable frequency drive. So it's just a drive that's changing the frequency that it's outputting, which is ultimately changing the speed of the motor. So that's why you sometimes hear these called VSDs, variable speed drive. You may also just hear them called drives or inverters or AC drives. But the important thing to know is that they're just changing the frequency of their output to change the speed of the motor. And if you want to understand a little bit better how motors work, we're not going to talk about it in this episode, but we do have a series on motor basics. So if this is new to you, go check that out for sure, and then jump back in here as we continue on talking about VFDs. So what is a VFD used for? Again, a VFD is really used to control a motor, but what are those motors used for is maybe a better question. Typically in the industrial environment, we see these AC motors used for fan applications, pumping applications, conveyors, really typically in continuous motion or constant speed applications, where, for example, a fan is going to just be spinning at some continuous speed. And this would be kind of contrary to the servo motor type applications where it's a bit more dynamic and position is really important. Here in a VFD type application, usually the most important thing is that we're hitting some given speed. And it may be controlled either manually by an operator, actually physically manipulating the buttons on the front of the VFD, or it could be connected to a PLC or other type of controller to actually use a control algorithm like PID to control the output of that VFD. But these are the three most common cases. There are obviously some more edge cases, but if you see either a fan, a pump, or a conveyor, there's a pretty good chance that there's a VFD in the system somewhere. So let's talk more about the VFD itself. So what happens inside of a VFD? There's really three main stages inside of a VFD that we need to be concerned about. And really our ultimate goal here is to take this AC input signal, convert it into another AC output signal, where we can change the frequency, because that's what's going to change the speed of our motor. So how we do that is a little convoluted, actually. It seems kind of counterintuitive, but what we're going to do is actually convert that AC into DC. So that's step one of a VFD. We're going to take our AC input signal and convert that into DC. Now that converted DC signal, this happens using a mechanism like a diode, where basically we're just chopping off the bottom part of that AC signal. And what that leaves us with is this DC signal that is a little noisy, let's say. So step two then is to take that noisy DC signal, where it's got a bunch of bumps in it, and convert that into a nice clean DC signal. We would call this filtering or something like that. We're using capacitors here to basically level out that DC signal to make it as clean as possible. And then step three, again, here's the crazy part. We've done all this work to get a nice clean DC signal. And what are we going to do? Well, we're going to try to turn it right back into an AC signal. But here is where we are using the VFD to actually change the frequency depending on what we need. So we're taking that clean DC signal now and then changing the frequency of the output AC signal. So again, to just summarize those steps real quick. Step 1, we take our input AC and turn it into DC. Step 2, we take that rough DC that we get and clean it up to get a nice smooth DC signal. And then the last step is to take that nice smooth DC signal and chop it up into an AC signal of whatever frequency we choose. Okay, so let's look at those steps a little bit more and get you familiar with some terminology associated with them. So step 1, this is called a rectifier. So all a rectifier does is it rectifies an AC voltage into a DC voltage. So that's step 1, rectifier. Step 2, we would call this the DC bus, DC filtering. There's a couple names here, but again, this is the step where we take that rectified DC voltage and we clean it up using some capacitors so that we can even out those bumps in the signal. And the last step, this is what we call the inverter. So an inverter is taking that DC signal, chopping it up into an AC signal. And here is where we're actually controlling the switching elements to change the frequency of that AC output. So it's really that simple. There's just 3 steps inside of a VFD. And ultimately what we get is a fluctuating frequency output, and that's going to change the speed, whether it's a fan or a pump or a conveyor or some other type of application. Our VFD is going to enable us to take that input signal, turn it into DC, and then back into AC at whatever frequency we so choose. And that's how we control our endpoint of, again, either the fan, pump, conveyor, or something else, setting the speed. And that's pretty much how a VFD works. So it's pretty simple. Again, coming up next week, we've got how do robot arms work. So make sure you check that one out. Subscribe and set up notifications if that seems interesting to you. And again, just as a last recap, a VFD seems like a complicated device, but it's really not that complicated what's happening inside of it. So if you just remember those 3 steps that we talked through, then you'll understand how a VFD works. And again, all we're trying to do is take this AC input signal and ultimately control it however we want so that we can change the speed of the motor on the other side. Because of course we want to control the speed of our fan, the speed of our pump, so we control the pressure of the system, or the speed of our conveyor so we can control how fast our products are moving. And we do that with the VFD. I'll go through it one last time, the 3 steps. The first one, we're rectifying that AC voltage into DC. That's a rough DC signal that we get at that first step. The second step is to just clean up that DC voltage. So we take all those bumps out of it and get a nice straight level DC bus. And then from there, we're chopping up that DC bus signal into AC, right? And that is where we can use the control inside of the VFD to actually determine how we're chopping it up so that we get the frequency that we desire and ultimately the speed that we desire at our endpoint. And that is how a VFD works. I hope you enjoyed this episode. If you did, please like below, share it with your friends, family, colleagues, and do leave us a comment if you have any other questions or have an idea for a new episode. Again, you can leave us comments down below, or you can always reach me at email, Corey@this-is-automation.com. Thanks again for joining us on this episode of This is Automation Live, and we will see you next time.